We move. All right. So, like I was saying, in today's class, we'll talk about database design and implementation, and that is coming as a follow-up to the project that we are supposed to have that I mentioned that you guys said you are interested in, okay? Which was to design a database system for a business, okay? Now, if you've not seen this, if you don't have link, if you don't have access to this link, I'm just going to put it on this Teams chat so you can check the charts and you'll find the GitHub page where you can follow through, okay? So all the scripts, all of the documents and everything for this particular project is hosted on this GitHub page, okay? So do well to check it out and so that you're able to follow along, okay? Good. So now, like I said, let me open my SQL Server. So literally, this particular project is all about building a retail database management system. So there's a company called Splendor Analytics Retail. It's a fictional company, and it is one that is rapidly growing. Search. Okay, it is one that is rapidly growing in the e-commerce. It has a physical store that specializes in selling consumer electronic, home appliances, and fashion items. And then the company operates across multiple locations and has an online store where customers can browse products, place orders, and track delivery. However, as the business expands, it faces several operational challenges due to its outdated and fragmented data management system. Okay, so currently, Slender Analytics Retail manages customer data, product inventory, orders, supplier information using spreadsheets and disconnected applications, which leads to data inconsistencies, delays in order fulfillment, stock mismatches, and customer dissatisfaction. So the major pain points for the company includes inventory issues, where customers place orders for out of stock products due to outdated stock data. Listen carefully, okay? Listen carefully and follow. You understand the project. It's very easy and very, very straightforward, okay? Then another issue is the order management challenges, where the orders take too long to process and tracking order history is difficult. Supplier coordination gap, customer service inefficiency, and lack of insight, okay? And now, to address these challenges, Splendor Analytics Retail has decided to implement a centralized high-performance database management system using Microsoft SQL Server. So it is this system, this database, that will integrate and streamline the company's operations, providing a real-time, structured, and optimized solution for managing the customers, inventory, orders, suppliers, employees, and analytics, okay? So the aim of the project is to develop a very, very robust relational database system for the company. And this would help in seamless data management, automation of the business operations, and efficient decision making. Can you guys hear me?
Yes, sir. Yes, we can hear
Yes, we can hear you.
you.
All right. So now the core functionality of the database is going to involve the customer management, that is handling customer registration, their orders and their reviews, the inventory management, order processing, supplier coordination, employee and department tracking. Now, this is the high level requirements. We said we need a database management system to handle the customers and all of that stuff. So the functional requirements. So the customer, now, when you go to a website, when you go to a retail website, let's say, for example, let's say Jumia, for those of us in Africa and for those of us in Nigeria. So if you want to register for Jumia, so you have to register by providing your personal details, and you can browse on the website to purchase your product, and you can also track your product, and you can write reviews after you purchase the product. And if a customer deactivates their account, their data should be retained. So I need, okay, let's use Jumia, for example, okay? So if you go to buy, if you are a new customer, you want to order something from Jumia, I believe that almost every one of us here has definitely placed an order either on Jumia or AliExpress or whatever retail or e-commerce store online, okay? So you have to register by providing your personal details. Then you can now browse and purchase these goods. You can now track the orders that you made, and you can write reviews after you made the purchase. And even if you deactivate your account, your data is still with that company. Now, you see all of these things that happen, all of those actions you take inside of a website, all of these actions are stored inside of a secure database. So all of this information, when you go to register for a website, when you do all of these things is going into a database that you're not seeing physically, but this database is at the back end. So that is literally what it is, okay? Then if now the product and inventory management part is that we'll store product details, that is the name, category, price, supplier, and the stock quantity. And we will manage real-time inventory update when a purchase is made from us, okay? And we ensure that the stock is not negative. And all of that stuff. You guys can read all of these ones. But then on the breakdown, on the layers, okay? So the project will be broken down into several phases, and each of them will focus on a core aspect of database development and implementation. One, we have the database design and normalization. So this phase is where we have to identify the entities and the relationship that have to exist inside of our tables. And then we now will normalize the schema or the table to the third normal form. And then we'll define the primary keys and foreign keys, okay? Now, this is going to be our table, or these are going to be our tables, and then we'll define the data type, the constraints, and the relationship that exists inside of these tables. Now, let me do a quick recap. Now, you see, in the previous class that we had, we talked about relational databases, okay? Now, we say that relational databases are types of databases that store data in tables, and these tables have relationships between them. You understand? So data inside of a relational database is stored inside of a table, and the table is literally what we'll be designing today, okay? Now, let me take you guys forward a little bit, okay? Let's talk about SQL a bit. And let me introduce you guys to the knowledge that you use to design this particular project, okay? Now, so in the last class, I told you guys that SQL is divided into 4 major sublanguages, okay? Into 4 major sublanguages. Now, the first sublanguage we have is the data definition language, which we also call the DDL as an acronym. There we have data manipulation language, that is also called DML as an acronym. Then we have transaction control language, which is TCL. Then we have data control language, which is called DCL. Okay, now we will start with the first one. These are the subset of SQL, and you see all of these subsets, all of these subsets, they contain commands that are used by SQL. Okay, this subset of SQL, they contain commands. Okay, now we will look at the first subset of SQL, or the first sublanguage, which is the data definition language. Now, let me ask you guys a question. When we say definition, what are we talking about? In English, I told you guys in the last class that SQL is English language. And if you must understand SQL, then you must have a proper command of English language, because the syntax and the rules that guide the way that SQL is written and the way it is being processed is based on the principles of English language, okay? So if you must understand SQL, then you must understand English language. So good. When we say definition, what are we talking about? Because we want to look into data definition language now. Anybody? Data definition.
The meaning.
When we say definition, we mean creating, defining something, bringing something to
Yes.
existence.
To define, yes. Something else, another thing. Anybody else?
To give meaning.
To create.
Okay, let me help you guys. Now, you see, the data definition language, which is the DDL, contains commands that are used is the subset of SQL that is used to define the structure of databases and database objects. So you see the commands inside of the data definition language, or this sub-language that is called data definition language. As a matter of fact, if you want to learn SQL, this is the first place you should start from, because this is the part that really talks about the foundation of SQL, okay? Now I'm gonna take my time. I need you guys to listen carefully. Like I said, if you listen to me, I will change your life. You understand? So, like I was saying, data definition language is the subset of SQL that is used to define the structure. Again, it is used to define the structure of databases and database objects. You know what a database is, but you may not know what a database objects are. So examples of database objects include things like your tables, things like your stored procedures, things like your views, things like your indexes, things like your constraints, things like your user-defined functions, and so on and so forth, okay? So this is the commands that are inside of data definition language. They are used to define all of these things, okay? So you can use those things. Now, there are a couple of commands that are inside of the data definition language, okay? Now, the first command inside of the data definition language is what we call the create command. We also have the alter command, and then we have the drop command, okay? Now, we would look at the first command, which is the create command. Now, you see the create command is a DDL command, or data definition language command, that is used to define the structure of databases and database objects. Okay, good. So it is used to create databases and database objects. Okay, now you see on this left hand side, if you open this left hand side, you will see all of the databases that I have here. Okay, so I'm just going to refresh this, because now I want to create a new database. I'm going to show you how to use the create command. Now we are talking about the create command. We'll see how to use the create command to create a database. So remember, it is used to define the structure. So to define could be creating, could be altering, could be modifying, or anything. Okay, so we want to create a database now. Okay, now we are going to create what is it called? We'll create a database for this particular project. Okay, so on this part, let me see my scripts. There is a DDL script. Okay, that is the data definition language script. Okay, good. All right. All right. So now the first thing that we would do is to first of all create the database using the create command. Okay. Now, but before I continue, you see I've been writing comments. You see all of these green things here in SQL, they are called comments, okay? So now there are two ways of writing comments in SQL. You either use the short line comment where when you put two dashes, two dash, it turns to a comment. You see, it turns green, okay? So this is the short comment. It only exists for that particular line, but on the next line, you see, it is no longer a comment, okay? And then we also have another commenting style, which is the longer commenting style, where you put a forward slash and an asterisk, okay? So you could write multiple lines and until you close it, okay? Which requires you to put the asterisk again, and then the forward slash, and then you see every other thing that we write here now is no longer a comment, okay? So that is basically, that is the two type of commenting style we use. Now, you see, comments are very, very important as a professional. When writing your codes, okay, you should always write your comments, because the comments, they help you to keep your codes clean. They help you to keep your thoughts in check, and make sure that you're writing your codes with a purpose. And for the fact that 3 months later, if you come back to this code, you may not even remember why you wrote what you wrote or the reason why you wrote what you wrote. You understand? So because of that, we need to have comments, okay? Good. So now I'm just going to start to create a particular, I'm going to create the database first of all. So the first one I'm going to call this, okay? So I could just, you see, I could put a whole lot of line here. You see, I could do a whole lot of stuff here, and then maybe, okay, give me a sec. Let me just do something fancy. Let me do something fancy. So I could just come here, do it like this. So let me put more. Okay, so I would say create the database. Okay, so this is my comment. Okay, and then I would close it like this. Okay, so now what I want to do is to create the database. Okay, so that is step one. Okay, you create your database. That is step one. Now, to create a database, like I told you, that SQL is English language. If you want to create a database in SQL, all you got to say is create database, and then you specify the name of the database. In this case, let's say, for example, let's say the name of my database is Splendor Analytics database, or whatever. Okay, so I could just call it whatever name I want. Okay, but I could just call it Sales DB. Okay, it could call it whatever you want, but the name of the company that has the database actually makes more sense. Okay, and then always remember to end your code with a semicolon. Okay, the semicolon basically tells SQL that I am at the end of my command. Okay, you see how easy it is to write SQL code. So we want to create a database. All we just got to say is create database, and then we specify the name of the database, which in this case is called SysDB. Okay, so you highlight the code, and then you come up here where it says execute, and then you execute. As you can see, it says that the command has been completed successfully. Okay, we've successfully created our database. So you come to your databases on this left-hand side, you right-click on it, and then you click on refresh. When you refresh that, you see that you have a new database that is called SysDB. Okay, there's nothing inside of the database yet. Okay, now always remember that now we've created this database. Like we said before, that in relational databases, data is stored and managed in tables. Okay, so you have a database. If you want to store data, if you want to manage data, you have to create a table, because the data is stored and managed inside of a table. So the next step for us is to create the tables. But before we do that, we need to make sure that we need to set the database that we want to use, which in this case is the sales DB. Okay, so all you just got to say is use sales DB here. Okay, and we enter. So if I highlight this code and execute, when you look up here, you see that it's going to change to sales DB. So if I execute this, can you see that it is automatically going to do that? Okay, good. So now I'm going to come down. So the next thing I want to do is to create, I want to create the customers table. Okay, so I'm going to create the customers table first of all. Okay, now let me just do that. So I will say create table. Then I will specify the name of the table, customers. Then I'll open up a bracket because inside of a table is made up of columns and data types, okay, and constraints. So we need to set up the columns and everything. So I'll come down here. So the first column you should always have inside of your table is going to be the primary key, and you should also set the data type for that particular column. Okay, we will set the data type for the column as integer. Then I will specify that I want this particular column to be an identity column where I needed to start with identity 1,1. Now this identity here, what it does is that it automatically assigns the power for this column or the values inside of this column to automatically increment. You understand? So this identity 1,1 confers the power for this column or the values inside of this column to automatically increment. Now, what do I mean? What I mean is, all right, so I'm going to take that again. So like I said, now we want to talk about the customers table. We want to create the customers table, and instead of the customers table, there are going to be columns, data types, and all of that stuff. So the first column we want to create is the customer ID, which is going to be the primary key, and we'll set the data type to integer. Okay, so we've already talked about all of this inside of the other class, which we recorded and asked you guys to watch. Okay, so we set the data type as integer. Then we'll set this column as identity 1,1. Okay, now this identity 1,1, what it basically means is that we need this particular column to automatically increment, okay, or increase whenever a new value is added into the table. Okay, now say for example, since I said 1,1, this first value here, we call it the seed value. Then the second one is called the increment value, which means that since I have said that it is going to be identity 1,1, I'm saying that the column should start reading from 1 and increase by 1. So if the first value is 1, what should be the next value?
2.
What should be the next value after 2?
3.
3.
What should be the next value after 3?
4.
And so on and so forth. That is literally what it does. So, and given that we've assigned this identity on that particular column, we do not need to insert a value into that particular column again. We don't need to insert any data into that particular column. The database would automatically use it by itself, assign values starting from 1, increasing by 1. Okay, so that is it. Then, obviously, the next thing is to set it as a primary key. Yes, what's the question?
So auto increment and identity works in the same way, right?
Yes, it is auto increment in my SQL, but it is identity in SQL Server. Then in Postgres, it is called serial.
Okay.
All right. So then the next thing we need to do, the next column we want to have is going to be the customer name. Okay. So say, for example, I'm going to set that to nvarchar 255. Okay. And then I'm going to set it to not null. We already discussed about all of this in the last class. Okay. So I'm going to also get the customer address. Okay, the customer address, I'm also going to set it to nvoucher 255, not null. Then I'm going to get the date of birth of the customer, and the data type is date. And I'm going to add a constraint to this particular date of birth to make sure that nobody puts their date back. So your date of birth cannot, your date of birth cannot be in the future. So your date of birth has to be less than that particular day. Your date of birth cannot be in the future. So I'm going to add a check constraint. So we talked about the check constraint in the last class. Okay, so where I'm going to say, I'm going to tell the database to check that this date of birth here, okay, this date of birth is less than or equal to today's date. So to get today's date in SQL, we use a function called the getDate, okay? And with this, it means that the date of birth, it means that the date of birth cannot be in the future. You understand? Yes, your question? Yes, Joshua. Okay, I'm going to proceed. Now, we also want to get, we want to get the payment reference. Payment reference, that is if the customer makes payment website. So we will set that to n voucher 50 characters, okay? And then we would also add a constraint to check that because we have certain payments. If you read the brief, you see that we have certain payments that can be accepted, okay? So it's either, so we'll add a check constraint to check that the payment reference in either of these value, okay? So it's either you used your credit card, yeah, it's either you use your credit card or you use PayPal. You must put all of these in single quotes. When specifying values or input values in SQL, you must put them in single quotes, okay? Or bank transfer. Okay, so then we close 1, 2, and that is it. Okay, so I think we have just 2 brackets to close there. Okay, so I'm going to put a comma. Yes, Charles.
Yes, sir. What does this particular constraint that you just did? What does it do?
What does it do?
Yeah, yes. Can you explain? Like, is it that?
Yeah, it's going to check. It's going to make sure that the only value or the only thing that can be used to make payment is either your credit card, PayPal, or bank transfer.
Okay.
You understand? You know, when you want to make payments online, they ask you to select an option. You see that the option is limited, obviously. True or false?
True.
So the option is limited to the ones that are available for them. So in our case, the only payment options that are available for us is either a credit card, your PayPal, or you're using a bank transfer. That is it. So you can only select either of these 3 values. Either of them. It cannot be anyone. So you cannot just come and be using some other thing to make payments for us. Okay? So yeah. That is it. Yes, Olaoluwa Adenuga.
First.
Adenuga.
Hello, can you hear me?
Yes, I can hear you.
Okay, so the argument we put into the identity, the 1,1, I want to believe one of the one is incremental. The other one, is it the starting point? The 1,1.
One is the seed, one is the increment. So the first one is the seed value. That is where it's going to start from. seed, like where it is going to
Okay.
germinate from.
So I'll
Yes.
thank you very much, because I was thinking if you want it to be like in a 4, like from 4 digits. So can we
No,
put
no.
1,000 there? Then
Yes,
multiply
yes.
from
So
1,000.
if you put 1,000 and say increase by 4, so the next value, the first value is going to be 1,004. The next one is going to be 1,008. The next one is going to be
Okay, thank you very much.
1,012, and so on and so forth.
Thank you very much. So the next question now is for this get date, is it getting today's date
Today's date,
or
yes,
date on the
today's date.
system?
Wait, let me show you. Yes, the date on the system. Let me show you an example. Let me say select
Okay.
get date. Okay, like this. If I say select get date like this, I like to execute. Can you see that it has gotten today's date to the
On time.
exact time, even up to fractional seconds? You understand?
Thank you very
SQL is
much. So
that
I just want to
smart.
clarify if it's the date on the system or the
It is the date. It's
GMT,
actually the
the
date on the
universal
system.
date.
It's the date on the
Thank you
system.
very much.
All right. Jennifer Eckert.
Okay, thank you. My question is for this customer name env chat in bracket 255 not null. Please, can you throw more light on it?
So it means that the customer name, your name cannot be more than 255 characters.
Okay.
And then every customer must have a name. So you cannot leave it empty.
Okay.
You understand? So when you go to, let's say you want to sign up for Jumia, you cannot leave the name, your name, the space that is needed to collect your name. You cannot leave it empty. And your name cannot be longer than 255 characters, except your name is Osanwenwenwe, Udumodi Black, Ugbe. So even if that's your name, it cannot be longer than 255 characters. Yes?
Okay.
So that's it. Yes, Michael David.
I think you've answered my question. I'm about to ask about the MPDACHA. I think you've answered it.
All right. Thank you so much. Okay, Jess. Jess, you're raising your hands. Please ask your question or I will continue. Okay, so I'm going to continue. Now remember in the requirement also, remember in the requirements, let me go back. Remember in the requirement, you would see that in the requirements, you see that we are required to collect their customer, their personal details and all of that stuff. Okay, so you can just check this. Okay, so the client's requirements. So the customers will provide their name, date of birth, and payment preferences, and we also collect their username and password for the online portal. Yes, Ebube.
Yeah, sorry, good evening. Can you hear me?
Yeah, speak out very well. Thank you.
Okay, so my question is concerning that, I think that, was it that get date or something? You've removed dates. So the check you wrote there, even on that payment reference, you wrote check. Please, can you explain further on that? The network threw me off, so I was not around during that.
You say what?
Said, can you explain it better? Like the network was bad when you were explaining that part. The check, like date of birth less than or equal to get date. Yes, that check around, and also the check for payment reference.
So this is the last time I'm going to allow any of you take me back because of your problem. Okay. So this check constraint is making sure that no customer is going to impute a date of birth that is less than that day that they are making their registration. You know, sometimes when you ask people to fill stuff online, just because they don't want to give you the accurate data or they just don't want to give you some kind of data, they will just decide to fill anything. But this particular constraint is going to make sure that whatever date of birth that this customer supply, it cannot be in the future. So it is either it is before today or it is today. You understand? So less than or equal to get date, which the get date is today's date. You understand? So for the payment reference, that's the same thing. It is going to check that you have either of these three options. That is the only three options it's going to show you. Either you use a credit card, either you use a PayPal, or you make a bank transfer. You understand? You cannot add any other payment type. So that is literally what it is, okay? Good. Odumegu. Odumegu and Shine. What's your question, please?
Okay, yeah. This is Shine. Please, can you hear me?
Yes, I can hear you.
Okay, so what if in a marketplace, in that check date now, in a marketplace, you want to make sure that those who are purchasing from this marketplace are people of age 18 and above? How do you check for the date that when they put it, it's going to show that from today's date backward, this person is age 18?
So we have to derive, we have to actually derive. Now, for it to be functional, now you could literally just say, what is 18 years from now? What is 18 years? What is 18 years back? What is 18 years back?
2007, right?
Yes.
So you could say that get dates, sorry, the date of birth must be less than 2007. Do you understand? But if you want it to be functional, if you want it to be dynamic in such a way where even after today, somebody else can still use it, like even if you've gone past 2007, because if you leave it at 2007, it means that you have to change it every year. You understand? So if we have to make it dynamic, then we have to do certain calculations on that particular place, which will actually take us a lot of time. You understand? So, but then it is doable. You get?
Okay, thank you.
All right. Udumegu and Njambi. These are the last questions I'll take. You guys, we've not done anything, literally.
My question is on the customer ID, the integer. If I would want my primary key to start off with an alphabet, like let's say C0, and the rest of the numbers
it is not
follow.
possible.
And
it is not possible.
It's not possible.
Yes. You have to derive that manually. So automatically, it is not possible.
So in the ERPs that have customer IDs that
yes, that is ERP or a CRM. Yes, it is set. ERP. It is set for ERP systems and CRM systems, not for normal databases like this.
Right. Thanks.
Yes, Odumegu. Okay. All right. So I'm going to proceed. Okay. So I'm going to continue. I'm going to continue writing this. Okay. So the next one, the next column we want to have is going to be the username of the customer. Let me just say username. Okay. Username. Let me say nvoucher 100. Okay. And then it has to be unique. Okay. Meaning that no two person can have the same username. Literally on Twitter, everywhere, every social media does the same thing, and then it cannot be not. So it has to be unique. So this unique constraint is going to make sure that everybody has a different username. And then I'm going to have a password hash. Okay, this is going to be a password hash. Let me give it the nvoucher 255, and then it has to be not null, so you must fill it. And then I'm going to add a marker that shows that the customer is active or not. Okay, the data type is going to be bits. Okay, because bits has just two values. It's either it is 0 or 1, where 1 is true, 0 is false, okay? And then I'm going to make sure that the default value is 1. You understand? So this is for account deactivation. This is for account deactivation, okay? So now I will come here and then I'm going to close my brackets, okay? So I am at the end of my command. This is the bracket I opened up here. So if I highlight this now and execute, as you can see, it says commands completed successfully. So if I say select everything on the customers table, if I highlight this and execute, you will see that we now have the structure of the customers table. And if you open your tables on this left-hand side here, see that we have a new table that is called customers. When you open the customers table and you check the columns, you find out that we have all of the columns. So as you can see, we have the customer ID, the customer name, the customer address, the date of birth, the payment reference, the username, password hash is active. And that is literally, we've defined the structure of that database object, which in this case is a table. Ladies and gentlemen, do we understand? Are we on the same page?
Yes, yes, yes.
All right.
Yes, sir.
Yes.
Good. So we
Yes,
have
but
another
please
table. We have another table. We have another table to create. Okay. So we have a lot to do today. So we need to create the product table. So I'm going to be faster this time. So I'm going to say create table, and then I'm going to call it the product table. And then I'm going to open a bracket. Same thing like we did the last time. So I'm going to have the product ID. That is going to be an integer. And then it's also going to be identity 1,1. And that is also going to be my primary key. Okay. And then I'm going to have the product name. And I'll set that to n voucher 255 and set it to not null. Okay. I'm gonna have hold on.
That you put 2 commas between.
Okay. Now there's something somewhere. I made a mistake. There's a table I need to create first. Okay, so I need to create the suppliers table. Okay, let me create the suppliers table before I create the product table, because we need to link the suppliers table to the product table. So we need to have a supplier ID here that is a foreign key that is creating a relationship between the product table and the suppliers table. Okay, so I need to create that first of all. So I'm gonna say create table, and then I'm gonna call it suppliers, and then I'm gonna open a bracket. So the first one is gonna be supplier ID. So then we would have the supplier name. The supplier name, that would be an n voucher 255, and then we'll set it to not null. Okay. Okay. Then I just want to have the contact info of the supplier that is supplying us the goods. Okay. Contact info, I'll set that to n voucher 255. There's a whole lot of stuff that I'm not able to discuss with you guys here. There's a whole lot of questions that I've not asked you guys. I want to ask you guys, but because I'm very, very short on time, but I'm just going to execute this table. As you can see, it says commands completed successfully. So if I select everything from the suppliers table, you'll see that I have the suppliers table here. If I select and execute, then you see that we have a column. Okay. So if I refresh my tables now, you see that we have another table on this left-hand side that is called the suppliers table. And if you check the columns, you see that everything is matching here. Okay, good. So now I can now continue on the product table. Yes, it's me. Sorry, pronounce your name for me.
DML.
What's your name? Pronounce it.
DML.
DML.
Yes.
All right. What's your
Please,
question?
can you just go back to the create table, the customer table? Let me take a picture. I have a syntax error and I'm trying to fix it.
You guys have morale. I should go back so that you should please come. All right, are you done?
Not this one, the first table.
All right, this is the first table.
Thank you.
All right, so I'm gonna continue with the product table now, and then that will mean I need to get the supplier ID. Okay, so I'm gonna say supplier ID integer. It references what table? What table is it referencing? For me to connect the product table and the supplier table, what table do I need to connect it to?
Supplier table.
Suppliers. On what column? What column is creating the relationship in the suppliers table? Supplier ID. Okay, good. Then we need to have another column for the price of the product. So I'm going to give that decimal 10,2. Okay, decimal 10,2. And then I'm also going to add a check constraint that is going to check that the price of a good or the price of a product is always greater than 0. You understand? Because you're not here to sell free products. Okay, so any product that is in our inventory, the price has to be greater than 0, meaning that it should not be free. That is a very good constraint. Okay, I think that is going to be the end of that particular table. Okay, so this is a foreign key that is connecting the suppliers, the product table to the suppliers table. So we say that this supplier ID here is going to reference the suppliers table on the supplier ID column. Yes, Charles.
Yes, sir. The decimal 10-2, can you just do a quick explanation on that 10-2?
Are you in the last class?
Yeah, I was, but I've forgotten. That's why I just said quick.
I explained it very well. Go and watch the video. I'm moving forward.
Okay.
I took time. I took over 5 minutes to explain it in the last class. All right. So the next one is the inventory. Okay. For those of us that were not here, let me explain decimal 10,2. I'm explaining because of them, not because of you, Charles. Okay. Now, the decimal data type is a type of data type that is used to store monetary value. Okay. So it is literally decimal P, S. So where the P means precision and the S means scale. Okay. The precision, which is the P, basically is talking about the total digits that that particular data type can contain. Okay, so in this case, the total digit it can contain is 10 digits. You understand? Is equal to 10. And then the scale, which is S, is the number of decimal places, which in this case is 2. So literally, I'm expecting that the values that are here could be like 25,000 dots. You understand this? Do you understand?
Yes, yes.
So we could have up to 10 digits, okay? So we have like this, 2, 4, 6, like this. So this is the full decimal, but you could have any value from 0 up to 10 digits, but it has to be 2 decimal places because monetary values are always in a larger currency and a lower currency. For us in Nigeria, this would be in Naira and this would be in Kobo. You understand? So monetary values are always that way. So yeah, the next table is going to be the inventory table. So I'm going to say create table and call it inventory. Then I'm going to open up a bracket, and then I'm going to have inventory ID, make it an integer, make it an identity 1,1, and also make it a primary key, comma. I'm also going to link it to the product table. Okay, so I'm going to link it to the product table because the inventory is literally the product. Okay, so I'm going to say product ID, make it an integer, and I'm going to make it. Okay, I've shown you one way of creating a foreign key. I'll show you another way of creating a foreign key now. But I'm going to make sure that this is unique and this cannot be null, comma. Then I want to have stock level. Okay, we should know the level of our stock. It's going to be an integer. And then we have to add a constraint going by what was defined in the project. Okay, going by. So the system has to validate stock availability before confirming the order. Okay, so we need to make sure of that. Very, very well. Very, very well. So I'm going to add a check constraint to say that stock level has to be greater than or equal to 0. Okay, so meaning that there can be no negative. There can be no negative stock. Okay, good. Then I want to have a column that's going to tell me when this was last updated. So the data type for this is going to be date time, okay, to store the date time. And I want the default value to be that particular day that we are checking it. You understand? That particular day that it was updated, okay? Good. Then for the foreign key, so I'm going to say that the foreign key is going to be on the product ID, where it references the product table on the product ID. Yes, that is it. Very simple, very basic, very, very basic, very, very straightforward. Okay, so I'm going to highlight this and then I'm going to execute. As you can see, it says command completed successfully. So I'm going to say select everything from the product table, and then I'm going to highlight, and then I'm going to execute. You see, we have product ID, product name, supplier ID, and then the price. Okay, good. So we have different more tables and different more tables to create. So I think I'm tired of writing codes. But yeah, let me see how to create the others table, and maybe I could get the rest or leave the rest. Okay, so the next table is going to be the orders table. So this is the table that we use to check the orders, that customer placed and all of that stuff. Okay, so same thing as always, we would say create table, and then we give the name, and then we will call this the order ID. Order ID, we'll make it an integer, and then we'll make it an identity 1. But first of all, before we proceed, let me show you something. Let me refresh this table. So the database. When we open the database now, you would see that we have what we call database diagrams here. Okay, you'll see database diagram. When you right click on database diagram, click on new database diagram. Okay, So it's gonna ask you if you want to wish to, yes, just say yes. Then you would see the different tables that you have, okay? You just click on add, 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 till you add all of the tables that you want to add on the database diagram, and then you can now close it, okay? You can now close it, okay? So you see, as of now, you see one table is not really related. One table is not related, but I think that's the table I was about to create now. Hold on, let me create the table first before I do that. So let me create the tables. Just hold on. I want to show you guys something. So primary key, I'll make this the primary key. Then I will add the customer ID. So now I want to create the relationship for the customer ID now. So I'm going to make it an integer, and it's going to be not null. Okay, so I will get the order dates. I want to get the order dates. That will be a data type, a date data type. And then I'm going to assign a check constraint that's going to make sure that the order date is less than or equal to that particular day that that person is making that particular order. Okay, so it is no future orders. Okay, it has to maintain that sanctity. Then I want to get the total amount. So that would be decimal 10,2. And I'm also going to add a check constraint. I'm also going to add a check constraint that is going to check that the total amount is always greater than or equal to 0. Okay, and then also I want to have the payment status. Okay, so we need to, the payment status is from the customer's table. Okay, so we have payment status, and then I'm going to set that to n voucher and n voucher 50. Okay, and then I'm going to check that the payment status, the same constraints that we use up here. So I'm just going to copy this, and let me just do this here. I'm just going to paste it. Okay, so it's either of this, it's the same thing. And then okay, it's not the same thing. It's not the same thing. It's not the same thing. This is supposed to be payment status. Sorry, forgive me. So status would either be pending. It's either the payment status is pending or it is completed or it is refunded. Okay, and then we would have a tracking number, and that would be nvarchar 100. Okay, and that number is going to be unique. No two person can have the same tracking number. And then obviously the foreign key, that is the customer ID, we would now set it up here. Okay, so we'll say foreign key is going to be the customer ID, and it is going to reference the customer's table where the customer ID, Sefini. Then we close the bracket, and then we highlight, and then we execute. As you can see, it says command completed successfully. If I select everything from the others table and then highlight and execute, it is going to give me the customer's table. Okay, so I have to refresh my databases, and then I have to close this. Okay, no. Now, yes, Charles, what's your question?
Yes. Sorry, I have two quick questions. The first one, instead of writing foreign key down, we can just write customer ID in int, then reference then do the way you did it the first time.
It's
I
not
just
me
like,
that
okay, cool.
I'm just showing you different method of doing it. We've done this
And-
one you're talking about before.
Okay. And then the second question I have, can you go back down, please?
Where?
Okay, for the tracking number. So basically, from what I understood from NVACHA, this tracking number means from 0 to 100. Right?
No, it's not going to be more than 100 characters. So it could be text, it could be alphanumeric, it could be numbers, but it's not going to be more than 100 characters. So from 0 to 100 characters, the tracking number.
Okay. All right. Thank you.
All right, so I'm going to go ahead and create and right-click on database diagrams, create a new database diagram. Now, I'm going to refresh this. Okay, so now in SQL or in data analytics or data itself, there are something that is called entity relationship diagram. It is the entity relationship diagram that shows the way the tables or the entities, also called entities, the way they are related with each other. You understand how data is flowing from one table, how the tables are connected, and you guys know it as data modeling. You understand? So, and in data, we have the one-to-one relationship, we have the one-to-many relationship, and we have the many-to-many relationship. Okay, so now I'm going to add all of this and I'm going to close this. Okay, you'll see that the database is going to create an automatic relationship between all of these. Okay, so, oh God. Okay, this is not complete. My stuff is not complete. I really forgot this stuff, but the tables are all related together. Okay, meaning that I still have to create more tables before it is all related. But yeah, I'm gonna get the next code. I'm not gonna be typing again. So I'm gonna get the next code. This is the other details. Okay, so we create the other details that handles the many-to-many between the orders and product table. So I'm going to highlight this. It's all here. I'm going to execute this. As you can see, it says commands completed successfully. I would refresh this database again. And then I'm just going to delete this one. And then I'm going to right click on this and create a new database diagram. I'm going to refresh this as well. I'm going to add till I'm done adding all of the tables. And then I'm going to close this. Okay, I think all of the tables are related together. So I'm just going to adjust this one. Just going to adjust it this way. Let me take it like this. Take it like this. All right. So now, this is the way data is flowing. So you see from the customers table to the orders table to the order details table to the products table to the inventory and to the suppliers.
2 weeks. See the under.
So
See here.
do we understand what we are saying here?
Yes, sir. Rational good.
Do you understand? So now, let me ask you guys.
Sorry, it's somewhat confusing. When did you create other details table?
I just created it now.
I wanted to ask the same thing, sir.
I just brought it in now. Are you guys not
Okay.
watching? What were you guys looking at? Just brought it in now. Okay. So now, you see that the relationship that exists between the customers table and the orders table. What type of relationship is it? Is it one-to-one relationship or one-to-many relationship or many-to-many relationship? Which one is it? The relationship between the customers table and the orders table. Is it one-to-one relationship or one-to-many relationship or many-to-many relationship?
It's one-to-one.
One-to-one.
One to many.
It is one-to-one. Who say one-to-one?
Hey, sorry, one-to-many. Sorry.
All right. Now, if you said one-to-many relationship, how is it one-to-many relationship?
because your customers, a particular customer with a particular customer ID can make several orders.
That's smart. Okay. Is that all?
Because you added things called unique there, which means customers have unique IDs, unique username, and unique serial numbers.
So what? Because they have unique. What now happened? What now happened because they have okay. Now,
Because
okay.
sorry,
Yes, Bukola.
because it's one to many, because there is customer ID on others on. Oh, sorry. Because I think it extends to others table and also to products. I don't know.
It's on the rap. Yes, Lauren Shaw.
There is a symbol at the bottom of others table that is showing that is many from the primary key, which is the customer table.
You are just telling me what you see. I'm telling you the logic behind it. I'm asking for the logic behind it. You are telling me what we are saying. You are following shortcuts. But then you are right, though.
Hello.
So he's right, actually. Whenever you see this infinity sign, whatever table has this infinity sign is the table with the many. You understand? But from this key is 1 to this infinity sign is many. So where the table you see the key is the table that has the primary key. So here in this customers table, it is the customers table that has the customer ID, which is also inside of the others table, this customer ID, which is what is creating the relationship. And because the customers table is the table with the primary key, that is why the key is showing on the customers table, linking it to the others table with an infinity sign or this edge here, which means that it is many. So from here, it is 1 to many. Now, let me ask you a question. The relationship between the others table and the product table, and sorry, the other details table and the product table, and the other details table and the others table, what type of relationship is it? 1 to 1, 1 to many, or many to many?
1 to many.
Many.
Many to 1.
To many to 1.
It's many to 1.
1 to 1.
Like if I catch anybody that is saying many to 1, me and you will fight. Like
But we are
1 to 1.
saying, sorry, we are saying with the explanation you made just now, we are seeing from that other details, we are seeing is it foreign key that links back to the other
like
table.
now the question is, now I don't know if you guys, maybe it's too much of Gary that you are drinking that is making you not to see where, or maybe you guys are just choosing not to see it. I really don't know how to explain this stuff. Let me ask again. This table that is called others table, what type of relationship does it have with the product table and the others table?
The relationship is products to other details, 1 to many. Then also others to other detail is also 1 to many.
Test 1 to many.
Oh God.
The order to product is 1 to 1.
I said other details, not others. Other details to product and other details to others.
Other details is the table connecting both.
1 to many.
There is no 1 to many there. The relationship,
Hello.
the relationship that is existing between the other details table and the product table and the other details table to the others table is called many to many relationship. You people now no go school. Are you kidding me?
I said many to many now.
You did not say it. 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 It was somebody, it's Joshua, that was saying many to many on the chat.
Can you explain how it is many to many? Because looking at the symbol, the symbol is saying different things.
How is it not many to many? You're asking me how is it many to many? How is it not many to many?
The symbol is there.
From here to here is many. From here to here is many. To many others. And many, that is like this. It is going back way and back and forward. And many others to many other details, and many products to many other details. They do not understand.
I don't understand though.
Clear.
Okay. Side of the product table can have many other details. True or false?
True.
You guys are not answering now. It is very simple. True or false?
True.
Many other details can have many products. True or false?
True.
Many other details can have many others.
True.
And many others can have many other details. True or false?
True.
Why?
You see, infinity sign is going from here. Infinity sign is going from here to here, from here to here. What do you think it means? The infinity sign, what does it mean?
Many.
It's false because it's backward.
The one here and the one here, what does it mean? Many to many now. This was the logic I was telling you guys about in the last class. I said we divide SQL into two. We have syntax and we have logic. You see, this part we are talking about is the logic. Do you understand?
Sir, please, me, I'm not seeing any infinity symbol. Everything is looking like the same thing to me.
Which one is everything is? Oh God! Now you they drink. Now you they blind.
Zoom your phone. Zoom it from your phone. You will see the difference.
Just zoom it. You see some kind of dots.
See now. See it now. It's not infinity. See it now. Let me zoom it again. Zoom and enter your eye. See, infinity is chain. Oh God! If I give you people chance, you will literally kill me. God, I don't die.
you for just say saku.
He say you look like rope. No, you look like choir. Well done. Oh God. All right. So let's proceed. Yes, please. What's your question?
That customer stable and other stable, the infinity symbol that is there and the key is the same thing as the infinity symbol that is in product and other details. There's no difference there. And you say customers and other table is one to many, but the other one is many to many. Is it from the symbol you are getting it, or from just the column's name?
How I want to explain this thing now? Like, okay. Abdullah, I beg, help me.
Okay, hello, good evening. Can you hear me?
Yes.
Okay. The madam that does ask the question, can you say hello to everybody?
Hello, good evening.
Good evening. So my name is Abdullah. So the question is I'm going to ask you questions. You know, this thing is logic now. Are you following? You have to open your mind, be open-minded. Now, what is the relationship between customer and others? Just tell me what you said earlier.
They said one to many.
One to many.
They said, what do you say? What did you say?
People said one to many.
Okay,
that
let's
because
continue.
infinity symbol is there.
Wait. You see now, let me just quickly correct something from everybody. I'm also a tutor too. So, but when it comes to our women, I have a soft spot for them. It's because of this type of responses they say. Now, I want us to put some things out of our mind that this is a class. Forget about everything they say. Since the facilitator has already given you ability to ask them questions, please, always ask directly. This one that all of them are saying, me, I don't understand though. Why is it like that? Not they say, because if you follow the bandwagon, you will miss a lot of things. Now, the idea here, is there's a customer that makes an order. One customer at a time can make plenty orders. Yes or no? Or when you go to ShopRite, is it only one thing you go and buy in ShopRite?
No,
Madam?
sir.
No,
sir.
good. So when you go to ShopRite, right, you will buy plenty things, isn't it?
Yes,
In
sir.
fact, you can buy plenty things different times, isn't it? So a customer can buy plenty things. Now, the facilitator, he has already zoomed that stuff too much and has told you that the one that you see the key in front means one. Are you following?
Yes, I'm following.
The one that has that 2 zeros means many.
Okay, sir.
Am I still on the way, sir? Mr. Uche, sir. Splendor.
Hello?
Splendor, don't go.
Are you done?
No, not yet. So now, key to infinity means one to many. So a customer can buy plenty. A customer has these orders. Now, when you are not taking it from a bigger place to you are now taking the one in between. For example, now he asked earlier orders and products, right? So you yourself, you will now tell me like this: between orders and order detail, what's the relationship? Based on that small explanation, Madam Kafilat, Abi?
I will talk.
Oh, yeah.
Between orders and other details. Is
orders
that what I'm
and
saying?
other details.
It's still key. It's still key and infinity
Key is
symbol
what?
that is there.
Yeah, so
Key is
key is
one.
what? And
Key
the
is
other
one.
one is what?
Many.
Many. So what does that tell you?
One to many.
So that's orders and other
details.
Now, between other details and product, what is there?
Infinity to one.
Key.
Many to.
So,
okay.
Meaning what? Many to one. Good. So now look at the way I'm bringing that statement though. I said between other details and products. So if I reverse it now, that between product and other details, you should know what it means. Now, before I now ask the next question from you, is that when they say one to something, meaning one order can have plenty other details, or plenty other details can be in one product can be in plenty other details. So if it's not telling you that what is now products and others, if the one in between, look at it though, products and others, you to think about it. You have different products and you have others. Looking at the keys are far from themselves, but the infinity is closer to themselves.
But you said product and other details. They said product and other details is many to many, not product and
said
others.
Product and other details. Splendor, did you say product and other details is many to many?
That's what they said.
Splendor, did you say
No.
product to other details is many to many?
No, you said products and others.
So that's what is product and others. That's the explanation, ma. So if you look between hello, you don't carry a commerce for.
See the code I wrote.
I did follow you since morning. I've been in the class since the beginning.
Uh-huh.
As I do interview for people here,
I did it.
They do.
I did it on purpose.
I know.
To say that these other details is going to be a junction table. It's going to be in the middle. Between
yes.
Orders and products.
So that's what you need to understand now. Think about it. Logic. The one in between. If this one is plenty, if it is plenty that is meeting this one, and it is plenty that is going out of it, if I remove it, it will mean that plenty will go and touch plenty. Sorry, I'm about to go back to my interview session. Okay,
Thank you,
can
sir.
take over, sir. Thank you, sir.
Thank you.
Thank you. Me, I'll not be entertaining you people's question. See this class, eh? See this class like this. It's not class to come and teach you ABCD and beginner stuff. You understand? If you want a class for that stuff, I think after the last class in the last week, a couple of persons decided that they needed to take SQL class. So they said that I should host a class for them that they were going to pay, and I said that I did not want to do that. They said that we have to do it. Okay, so they said that they were going to pay 15K for the class for fuel and data. So in case you're a beginner here, you don't understand these things, you are finding it very hard to maybe you still don't understand the basic part of, see, this class is because of a project, not because I want to explain basic SQL. You understand? I'm just trying to help out with the project. So if that's what you want to do, just please on the group chat, just indicate interest there. I think they will somebody is going to take care of you on that, take care of you with that you get. So you register for a class that is going to drill you very well on SQL, get starting from basic. Okay, so let's continue. I still have more tables to create, so I'm just going to copy the next one. I'm tired of typing actually. So the employees table. So this is going to be employee name and the employee role. Okay, but before that, we need to create the departments table. So I'm going to bring in the departments table. And then I'm going to put that down. Let me create the departments table first of all. Let's see the departments table. Okay. So we highlight, we execute. Okay, that's the department table. So now I now create this. So this would be employee role from department table.
Yes. So your employee name is not spelled correctly.
What?
Employee name.
Employee. Thank you so much. Thank you so much. So this will be on the department table. So yes. So let me see the employees table. Select everything from employees. Okay. Highlight and execute. All right. So I think we are good on that. So then we need to get the customer reviews as well. So we need to get the customer reviews. It was asked on the project. So I'm just going to highlight this and then execute. Okay. So yeah, let me see. Let me refresh my database and create another new database diagram. I'm going to refresh this as well. Add, and add till I'm done adding all of the tables. I don't know if I completely, oh, there's another table that I did not create. There's a table I did not create. So now the question is going to be, how do we link the employees to all of these things now? So let me create the payments table first of all. So I need to create a table called payments. This is where we're going to handle all of the payments. Okay. So how do we connect the employees table or department table to the other tables that we have there? How do we do that? Wait, let me show you what I'm talking about. I'm going to add all of the 11 tables that we've created. I'm going to add this completely. Then I'm going to close this. All right. So you see that these two tables are now separate. So how do we do it? So that now employees, who are employees for this business? I want to get something from you guys. Who are employees for this business? In a retail store, who are employees?
Those that work there.
Cashier.
Okay.
Cashier.
So yes. So which table do we need to connect the employees to? That's where it's gonna make sense. Where it has to be where it's supposed to be, because it is not every type of data that the employees are supposed to get their hands to or get access to. But yeah, how can we create this connection?
Department.
Already connected to department now.
It is connected to department, but department is not connected to anything. Can't you see? These two relationship here is single. It's not even related to this other one. See, it is isolated.
They should be connected to product or inventory.
Inventory or product. Connected to payment.
Inventory or product.
And inventory.
Payment.
Can be connected to payments and reviews.
I don't understand you people.
Okay, we can connect it to products. We can connect it to inventory.
Inventory and
We can also connect to payment. We can connect to payments, and we can connect to reviews as well.
So which one is it going to be? Inventory. Why? Okay, if we agree that it is inventory, what are they doing in inventory?
They are checking the stock levels of all the products, the ones that are finished, the ones that are still available, and the ones that are about to finish.
Okay, that's not bad. Yes, Hassan.
Yeah, there also updates the inventory and the payments also. They're connected to payments.
You should add employees to payment.
Yeah, cashier.
The payment is also not connected to
But I think you can connect customers because employees are attending to the customers.
Why do we connect it to customers? If we connect it to customers, it means that they can see customer name, date of birth, username, and password, which is wrong. Logically,
I don't think
it is wrong.
Customers. I don't think it's ideal to connect it to customers. This information are sensitive information.
Connect it to others.
I can't hear you.
Connect it to others.
It can be connected to suppliers.
No.
I don't think it should be connected to supplier at all. Cashier doesn't have anything to do with supplier.
You guys are just guessing for me. I need somebody with sound logic.
So I actually manage software inventory software. So from the software, it's usually the cashier that handles payments. That's why I suggested payment. And manager also handles updating of new products. That's why I was thinking it should be payment and product side.
Okay. Now, is it product or inventory? Because the inventory is the stock level, but product is just the product that we want to sell. The inventory, that's the stock level, what we have in stock and all of that stuff. Is when we have something in stock that is going to be listed on the product.
Me,
But I
Is
think it's the inventory
inventory.
because there should be somebody in charge of that, maybe the manager or someone. So I think it's
But,
inventory. It can't be
but
the
wait,
product.
so we know that the employees in that place have hierarchy. And as the hierarchy goes, that's where the departments are limited to.
Okay, let's put it on. Okay, give me a second. Let me see. Let me calculate something because I don't understand you people. I purposely left this stuff blank here so that we would think, but you are
Sir,
not thinking very well.
the other stable, please. They can be connected to the other stable. Hello, can you hear me, sir?
No. Not other stable. We cannot connect it to the other stable. So if at all we want to connect the employees, we have to connect the employees to inventory and payments. Do you understand? So that the procurement department, administration department, warehouse department, or marketing department will have access to the data from payment and data from inventory. Do you understand?
Yeah, I guess yes. And these two places, they have other ID there, they have product ID there. Yeah, so there
So you see, it is related.
amount and they are related to other areas as well. That's
Good.
fantastic.
Good. So because we need to create a relationship between the employees table to the payments table and from the and from the employees table to the inventory table, that brings us to the next thing in the data manipulation language command, which is the alter table. You understand? Okay. So the alter table. We've talked about the create table. Now the alter command is used to modify the structure of databases and database objects. If your mic is off. All right. So like I was saying, everything in a database is an object. Okay. And if you've created an object, you cannot really just, if you want to make changes to that particular object, you cannot just go and clean your code because we are writing code here. You cannot just go and undo the code or change it and say, okay, it is going to take effect. No. You see, all of these tables we've created, these tables are objects. You understand? So if you want to make any change to the object that you've created, then you need to alter the structure of that particular object, which brings us to the alter command. This alter command is used to modify or alter the structure of databases or database objects. Okay. Now, if we want to add the, what is it called? We want to add the employee's ID. So now how do we do it? Do we add employee's ID to the payments table and the inventory table, or do we add the inventory ID to the employees table and to the payments table to the employees table? Let me see what you guys think. Which way does it go?
We'll add the payment and inventory to the employee table. We can't add employee to. Have it? Yes.
So we have to alter the table. So to alter table, you say alter table, then you specify the name of the table you want to alter, which in this case, let's say we want to alter the inventory table. Okay. If we want to alter the inventory table, then we would say add employee ID, make it an integer. You understand? And it can be null. Okay, it can be null for now. Know what I'm doing? Then you execute this, okay? So let's check the inventory table. So I'm going to refresh this database. So when you check the tables and you check the inventory table and you check the columns, you will see that we have a new column called employee ID, okay? Now, to make this employee ID a foreign key inside of the inventory table that's going to connect the inventory table and the employees table, we have to say alter table. You specify the name of the table, which is inventory, and then we say this is alter.
Sorry.
This is alter, okay? So we say add constraints. We add constraints. Then for the constraint, okay? So I'll call it is a foreign key. So I'll say foreign key inventory employee, okay? So now I have to say employee ID references. I'll make it an integer.
Integer references
That
employee.
it references the employees table on the
Employee ID.
employee ID column. Wait. Employee ID integer references employees table on the. Okay, I have to specify that this is foreign key. Put it in brackets. All right, so now let me refresh this column. Can you see that automatically it is now the foreign key? So it is now related to the employees. Okay. I'm going to copy this, and then I'm going to change the table from inventory to payments. Is it payments or payments as in plural? It is payments. Okay.
In plural.
Then I'm going to execute that, and then I'm going to order the table. So same thing, it is payments, and then I'm going to change this to foreign key payment employees. Okay, then I'm going to execute. So let's open the payments table. So check the columns, see that we have the foreign key. Okay, so now let's refresh our database. Okay, let's create another database diagram. So right click on new database diagram, refresh all of this, add to completely add the 11 tables. Okay, so let's wait for that to load up. Okay, so I'm just gonna close this. Okay, and voila. Very sweet ball. Very sweet ball. How is it now? Is it sharp?
Masterpiece.
Who say my screen dey lag? Now you go
Baba,
lag.
screen the lag. Only me. I know I talk since.
Oh, wow.
I did tell you.
Okay.
Oh, they follow up. Very good.
All right. So far, so good. Do we understand?
One.
So far, so good. Do we understand?
Yeah, understand.
Okay, give me a second. Let me switch up on the network.
That's almost it.
All right. So yeah, thank you so much. Okay. So we are good with this. So what is the next step? What is the next step? Now we have created the schema. We've created the relationship. Okay. So now we need to populate the tables. Yeah. So we need to add records. So you see all of our tables, they are just structured and skeleton. You understand? So now we need to add the records into the table. Okay. So we want to insert the records into the table. Okay. Now, what was the first table that we created? What was the first table that we created? Customers table.
Customers.
Customer table.
Okay, okay. So you insert the table the way you created it, except you want to face errors. Just insert it. Okay. So start with the customers table. I'm going to show you how to insert data into a table. Okay. Now, you see, that brings us to the next subset of SQL, which is called data manipulation language. Okay, data manipulation language. Okay, now this is a subset of SQL that is used to modify and manipulate data that is already within a table. You understand? So it is used to manipulate and modify data that is inside of a table. You understand? So it works with data that is inside of a table. So there are different commands in data manipulation language. We have the insert into, we have the delete, we have the update, and then we have the select. Okay. Now to add new rows of data into a table, like we want to insert new data into the structured table that we just created. Okay, good. So now the insert into is used to add new rows of data into a table. Okay, so to insert data into a table, you say insert into, then you specify the name of the table. Let's say our first table is the customers table. Okay, so let me check the columns. So you need to specify the columns that you want to insert data into. Okay, so I can see that we have the customer name. Okay, comma. The next one is the customer address, comma. The next one is the date of birth, comma. The next one is the payment reference, password hash. Okay, good. So now you now specify the values. Okay, good. So the first row of data you will add. Somebody give me a name. Give me a name. Give me a name. Okay, Bukola. So we say Bukola Emmanuel. Okay, so that is the first name, comma. What is the customer address? Let's say 23 Ikorodu Street. Sorry, Ikorodu Road.
No.
Lagos. Okay, comma. That is the address. Date of birth, let's say 1985. July the 14th. And then let's say your payment reference is credit card. And then your username is Books, baby.
Yes.
Then let's say your password is let's say Bukola Emmy 1. Then you close the bracket. You understand? Now, who can tell me what they notice from this code, from this thing that we want to insert now? This query that we want to insert now. Who can tell me what they notice? What do you notice? Look at the columns we have here and look at the columns that we have that we are inserting values into. What is changing?
We didn't.
You say what?
It is written in red. The values.
You say it's written in red.
We didn't have customer ID because we had specified it already.
Oh God.
We didn't put customer ID because we specified the identity already.
Good.
Exactly.
We did not put customer ID. We did not include customer ID in the columns we want to insert data into because we specified the identity keyword for the customer ID, which automatically gave the database the power to automatically insert data into that particular column. You understand? And given this right now, if we insert this particular record into this table, it is going to assign an ID automatically for this record. So if I execute this and then I say select everything from the customers table, and then if I highlight and execute, can you see that we have a customer ID 1, identity 1,1 starts from 1. This is the customer name, customer address, date of birth, payment reference, username, password hash, and this customer is active. True or false? Clap now.
True. Active.
All right. So yeah, that is literally what we have. Okay. So we can go ahead to insert as many records as you want to insert, but this is where I'm going to stop for today. Okay. So you go ahead and insert records into the table. Okay. Go ahead and insert records into the table that we've created and make sure that the records you are inserting are correct. It's looking like we would have another class, but that is based on probability as of now. Okay, so I want to stop here for today's class. Okay, but I believe I've given you guys a lot of insights into the project. I mean, we've been able to design the database in the third normal form, and we've also created a table. It's just to populate it now. We've added all of these constraints. Okay, it's meant just to populate it and then do all of the querying. Okay, so yeah, that is what it is. Then we have to do stored procedures and all of that stuff, but that's going to be later because you people have not even understand how to create table, talk less of stored procedure. Okay, now, well, that'll be all. Okay. So, and for those of you, here's my advice for those of you who you know that you're not solid in SQL, but you are just looking for how to rugged it. You're just looking for how to like do it by street way. Learn from here, learn from here. It's not gonna work. Get your basic very straight and you'll figure out every other thing. Okay. So yeah. And for those of you who will be interested in that class, so you can just indicate and they will take care of it. Okay. That will be all. Let's talk in the class. Let's talk in the class. Please. I don't want this video to go past this. Let's talk in the class, okay? I'll see you guys soon. Bye.